I'm Evan Zapwell, the chairman of the board of the Welch Foundation, and I want to welcome each of you here today for this auspicious occasion. We're here to designate Paul Cremer, professor of chemistry at Texas A&M University, as the 2006 recipient of the Welch Foundation's Norman Hackerman Award in Chemical Research. Dr. Cremer is the fifth scientist to receive the Hackerman Award. Dr. Cremer's research lab is truly a model for interdisciplinary exploration with many far-reaching, unique applications. Today we're recognizing him not only for his scientific ingenuity, but also for his critical instincts, his extraordinary insights, and also as a mentor for aspiring young chemists. We're really excited that such a brilliant young star is here in Texas. And we are particularly excited that Dr. Cremer has come so far, so fast, that in just 7 years at Texas A&M, he has risen from a junior faculty member to a full professor with a worldwide reputation in multiple areas of surface science research. His remarkable journey in physical chemistry has already had a tremendous impact. Now, they say a picture's worth 1,000 words, so turn on the projector, and we'll see if that's true.
Fascinated with how nature works, Paul Cremer is on a quest to unravel the basic molecular principles of biological interfaces. Using scientific instinct and ingenuity, he designs new techniques that are catapulting surface science research beyond what was previously possible. As a professor of chemistry at Texas A&M University, he is uncovering answers to age-old questions, pioneering new frontiers in chemical research. Today, the Welch Foundation honors this rising star with the Norman Hackerman Award in Chemical Research for his trailblazing contributions to physical chemistry and biological surface science. Named in honor of longtime Scientific Advisory Board Chairman Norman Hackerman, this award spotlights young chemical researchers in Texas who are performing groundbreaking work.
He's indicative of the young scientist. He's very broad and has capacities way beyond his own field. I think he's going to contribute both to what we know about nature and to outcomes of value to the human race.
Born in Chicago, Illinois, to a chemistry professor and elementary school teacher, Paul Cremer was exposed to the thrill of scientific discovery at an early age.
Right from the very beginning, my father was a great influence on me because I was able to see up close the sorts of things that a scientist actually does for a living on a daily basis, trying to understand problems and to tackle new frontiers in science.
Intense curiosity drew him to science at the University of Wisconsin-Madison, where he graduated with honors and distinction in 1990. After receiving a doctoral degree in chemistry from the University of California, Berkeley, Dr. Cremer spent 2 years at Stanford University studying lipid membranes as the American Chemical Society Siegel Postdoctoral Fellow. His broad knowledge and impressive reputation inspired the chemistry department at Texas A&M University to create a position for him in 1998. There he began studying the physical chemistry of biological interfaces. Undeterred by the limitations of technology, Dr. Cremer frequently developed new analytical techniques to make observation easier. Among his most acclaimed is a temperature gradient microfluidic platform that enables simultaneous experiments to run on a tiny chip.
His impact on really what you can do and what you can learn from these experiments on a chip revolutionized this sort of technology.
Equally as impressive as his inventive techniques are the long-standing problems they have enabled him to answer, such as the Hofmeister effect. In 1888, Franz Hofmeister showed that when the type of salt within a solution is changed, the proteins that salt out of solution follow a regular series. But for more than a century, no one knew why. By using his laser-based and microfluidic techniques, Dr. Cremer made significant progress in resolving this problem. The findings have implications for areas ranging from protein folding to cell-cell signaling.
Intrinsically, he's extremely intelligent and he's creative, and he has a unique background, unique experience that combines the good basic physical chemistry with an insight into the biological area.
His broad knowledge has enabled him to contribute greatly in diverse areas of science. By studying the interactions of blood-clotting proteins with man-made surfaces, Dr. Cremer's team uncovered key molecular-level details that should help determine whether artificial materials used to make hip implants will be accepted or rejected by the body. He has also shed light on how pathogens interact with cell membranes, advancing scientific understanding of how inhibitor drugs work. Away from the lab, Dr. Cremer enjoys spending time at home with his wife, Chris, whom he met 20 years ago in college.
Paul's a lot of fun to be with. He's very serious a lot of the times. His job requires him to be, I think, but he has to goof off sometimes. So we do have lots of fun together.
Married for 12 years, the couple's favorite pastime is raising their children, Stacy, 3, and Michael, 1.
One of the interesting things about small children is that they're kind of like scientists. You know, once we get an answer to one thing, you're already on to the next why to see if you can put together a full puzzle.
His passion for discovery inspires his family, colleagues, and students alike.
He has this uncanny way of challenging the students to excel and to move along at a good pace. And it helps instill in them the same kinds of work ethic and curiosity that he possesses.
What really interests me quite a bit is when they have that first spark of recognition, when they first get a concept, like, aha.
He, I think, enjoys working with his students tremendously. He is definitely somebody that impresses me as being in his element as a scientist. He lives and breathes science.
Dr. Cremer's unrelenting curiosity has driven him to the frontiers of chemical research and beyond. At only 38 years old, he has already earned a worldwide reputation as a leader in molecular surface chemistry. But what excites him most is knowing that he's merely scratched the surface of the mysteries yet to be solved.
The fact that we can start to get at a molecular understanding of how proteins work, and especially in conjunction with surfaces, is probably opening up new fields, not just within chemistry or biochemistry, but within medicine and potentially within technology.
I think we're all lucky if we can make an impact in a single area. I think he's made impacts in lots of different areas.
For his scientific ingenuity, boundless energy, and unwavering pursuit of fundamental knowledge, the Welch Foundation salutes Paul Cremer as the recipient of the 2006 Norman Hackerman Award in Chemical Research.
Now I want to call on the man himself, Dr. Norman Hackerman, to give us his unique perspective with respect to the accomplishments of Dr. Paul Cremer. I might say I've been on the Welch Foundation for I don't know how many years, but Dr. Hackerman has been on there longer than I have, more than 20 years, and he is the heart and soul of the Welch Foundation.
Paul, you may not know this, but I'm a colloid chemist, and I knew the Hofmeister series before you were born. That was one of the key elements of colloid chemistry back in the 1930s. The difference is we knew a fair amount about how nature worked back in the 1930s, but we didn't understand much of it. And in fact, it wasn't until the late 30s when quantum mechanics and density functional theory converged that we began to have major improvements in our understanding of nature. Not knowing about it, but understanding it. And in the last 2/3 of the last century, the development of theory, which was reliable, and the development of very inquisitive, sensitive instruments made it possible to do experiments which leapfrogged with theory and vice versa, and led us into a learning period which can be described as exponential. And Dr. Cremer is a great example of what it takes to be a first-class scientist in the early 21st century. The ability to design experiments to answer very difficult questions. Lots of people can do simple questions, but difficult questions. And in his case, the ability to design instrumentation along with the computers that he has and the lasers that he has to carry out experiments at the interface, which is the area I'm particularly interested in myself, and get to know in detail and with some affection the individual molecules. Not just the field, the interface, but the molecules sitting in the interface. Now, with the capacity to understand forces and the way they affect materials, and to do the exquisite experiments that are being done these days, we're going to make great leaps. And he's a leader in these great leaps already. So given that he doesn't get diverted to some peculiar thing that's of no consequence, he can make tremendous advances in the scientific field. It's a fact that the good scientist in 2005 can make advances which would take a lifetime for the scientists of the early 1930s. And to be a leader in that field is indeed a wonderful thing. Congratulations.
All right, we're now this is payoff time, as they say. I'm honored to invite Dr. Cremer to come to the podium to receive the 2006 Norman Hackerman Award in Chemical Research. And I'm going to have to come around here, Paul, because it's 3 parts. And the first is this certificate acknowledging you as the holder of the Norman Hackerman Award in Chemical Research. And if you would just move a little bit. Okay. The next is the sculpture here of a rising star to demonstrate what you are in the field of chemistry. I might say you're not a rising star, your star has risen. And you're planted firmly in the firmament. But I want not to neglect to give you what please after is this check for $100,000.
Wow, it's a real honor for me to win the Hackerman Prize. And I'm really grateful to Dr. Hackerman, to the Welch Board, to the Advisory Board, and to have won it. It's a rather new award, but already to be sitting here with Andy Barrett, who is the first Hackerman Award recipient, and the subsequent ones, I was truly thrilled to win it. The Welch Foundation has done so much for chemical research, basic chemical research in the state of Texas. And still, to me, the most important thing when I first got here, when I first started in 1998, it was very impressive to me that the group of us, it was one of the first things we did is we wrote in for the Welch Foundation for a Welch grant, and it helped start my very first projects going using lipid membranes. And subsequently, they've always encouraged, in fact, Dr. Hackerman has always encouraged, even when you're working on a project, if you come up with some new insight, some basic fundamental understanding that takes you in a different direction, he's always encouraged this. And this, the freedom to really study basic chemical sciences, is an asset that we have in the state of Texas. So thank you once again so very much, and I'm so very pleased to have won this award today.
Thank you, Paul, for those kind words. That was music to the ears of all of us that work at the Welch Foundation. I want to thank each of you for coming to today's proceedings, and wish you Godspeed this afternoon. Thank you very much.